converging, diverging sequence or series. So I've got a series here, 1 plus a half plus a quarter plus an eighth. I'm going to say that the common ratio is a half. Okay, I've got another one here, 1, 2, 4. I'm going to say that the common ratio is 2. So this here, this would be a converging series. Why is it a converging series? Because if you have 1 and then a half and then a quarter, an eighth and so on, it's eventually going to get to 2, isn't it? It's going to converge on a certain number where it's going to stop. And it will, it will never quite get there, but right at the end, after an infinite number of terms, it will get there. It's going to converge. Compare that to this one here, 1, 2, 4, 8, 16, 32, 64, etc. This is just going to diverge. So it's not zeroing in on a particular value. And we can do this with other ones as well. Let's make up another example. So 1 minus a quarter, a 16th, a 64th. Here r is minus a quarter. But can you see it's sort of just bumping around the number 0? Okay, so we're going to say that for these smaller numbers that are less than 1, whether they're positive or negative, so if I want whether they're positive or negative, I can write it like this. If they are less than 1, when you raise this common ratio like a half or a quarter, think about some small decimal. When you raise it to a very large number, it's going to get very, very close to 0. Okay? So we're going to say that if we're in this situation here, then for an infinite number of terms, it's going to be 0, isn't it? This common ratio applied an infinite number of times is going to be 0. And we can use that in this formula here. So we're going to replace where it says r to the n, because n is really approaching an infinite number. So 1 minus 0 over 1 minus r. That's rn, so they're not the same. 1 minus 0 is just 1. So this is my formula for finding the sum of an infinite series. And that's where this one comes from here. What we can do with it now is we can sort of take some numbers and plug them in. So let's do the initial one. The initial one we said for 1, a half, a quarter. We said a is 1, r is a half. What's going to happen? It's 1 over 1 minus a half, which is the same as 1 divided by a half, so it's 2. So there you go. We've actually shown where that result now comes from.